Intermediate first year physics, new syllabus and a new chapter, unit number 14, physics of emerging technologies. The definition is emerging technologies are newly developing technologies based on scientific principles that have potential to greatly improve human life, industry, medicine, communication, transportation, and space exploration also. For that, physics plays an important role in the development of modern technologies. Concepts such as electricity, magnetism, semiconductors, optics, quantum mechanics, and thermodynamics are used in advanced technologies. Emerging technologies combine physics with computer science, biology, engineering, and material science also. These technologies help in faster communication, better healthcare, smart machines, energy conservation, space exploration, automation in industries. Examples for emerging technologies, physics of emerging technologies are artificial intelligence systems, robotics in industries, nanotechnologies in medicine, quantum computers, fusion energy reactors. That next topic is artificial intelligence AI and machine learning in physics. Definition: artificial intelligence is the ability of machines to perform tasks that normally require human intelligence, whereas machine learning is a branch of AI where computers learn from data and improve automatically without explicit programming. Here the detailed explanation is AI and ML, artificial intelligence and machine learning are widely used in physics research and technology development. They analyze huge amounts of data quickly and accurately. So what are the applications of AI and ML in physics? That are predict weather and climate, detecting particles in the experiments, space research, medical imaging, smart automation. These are the applications of AI and ML in physics. Now, what are the working principle? Data is collected by AI and algorithms analyze patterns and the system learns from previous results and the predictions or decisions are made automatically. So what are the advantages of AI and ML in the physics? It saves time, reduces human error also, handles complex calculations and improves accuracy. Some of the examples where we use AI and ML in the physics: face recognition systems, self-driving cars, virtual assistancy like Siri and Alexa, AI-based medical diagnosis, recommendation systems in YouTube and Netflix, etc. And next chapter, physics in robotics. In robotics, how physics is applied. Robotics is the branch of technology that deals with the design, construction, and operation of robots. Robots actually works using the principle of mechanics, electronics, sensors, artificial intelligence, and control systems also. Physics helps robots to move, balance, to lift objects, and to interact with the environment. So what are the components of a robot? It has sensors, controllers, actuators or motors, power source, and a programming system also. So what is the uses of the robotics? We use robotics nowadays in industries, hospitals, military and space machines, and as well as domestic works also. We usually see in the restaurants some robots are serving like that. These are some examples where the robots are used. Industrial robotic arms, and where human being can't work, we use industrial robotic arms. And surgical robots, humanoid robots also, Mars rover robots, vacuum cleaning robots also nowadays we are using. Next, physics of nanotechnology. What is the definition? Nanotechnology is the science and technology of materials that at a nanometer scale. Nanotechnology is the science and technology of materials at a nanometer scale. So at nanoscale, materials show unique physical and chemical properties. So these are some important features of the nanotechnologies. Very small in size and large surface area, high strength, and nanomaterials are better conductivity, having better conductivity. So where we apply these nanotechnology? Medicine, electronics, energy storage, water purification, and strong materials. If you want to make, we can use nanotechnology. What are the advantages of the nanotechnology of physics? Faster devices, better medicines, lightweight materials, improved efficiency also. Some of the examples of nanotechnology: nanomedicines for cancer treatment, nanosensors, the carbon nanotubes. They are very small in size but very strong, and the nano coating on glasses, nano batteries, etc. Next topic is quantum technologies. Quantum technology uses principles of quantum mechanics such as superposition and entanglement. Quantum physics studies the behavior of particles at atomic and subatomic levels, like electron, proton, and neutron in an atom. So what are the important principles of quantum technologies? Superposition, quantum entanglement, quantum tunneling. Some of the applications we can see here: quantum computing. Nowadays it's a very high booming quantum computing. Secure communication, high precision sensors also. So what are the advantages of the using of quantum technologies? extremely fast calculations, and better cyber security, high accuracy measurements can be done. So you can see some examples of quantum technology. Quantum computers. So now the technology is going on in quantum computers, quantum cryptography, quantum sensors, atomic clocks, quantum communication systems. And next chapter, fusion energy. Fusion energy is produced when two light atomic nuclei combine to form a heavier nucleus and release enormous energy. Fusion is the process of occurring in the sun and stars. So common fusion reaction is done. Hydrogen nuclei combine to form helium. So do you know what are the conditions required for the fusion energy? Is very high temperature, high pressure, and it should be in the plasma state also. So if you provide all these conditions, there are some advantages: huge energy output, less pollution, no greenhouse gases, and the fuel is abundant. Some challenges are also there for this fusion: difficult to control, and it requires extremely high temperature. So where are the some examples? Sun's energy production, tokamak reactions, ITER fusion projects, hydrogen bomb principles, plasma fusion experiments also. Next topic is advanced smart nanomaterial science. So smart nanomaterials are materials that can change their properties automatically in response to environmental conditions. So these materials react to temperature, pressure, light, electricity, magnetic field also. Smart nanomaterials respond to temperature, pressure, light, electricity, and as well as magnetic field. So it has some characteristics like self-healing and shape memory, high sensitivity, adaptive behavior also. Some of the applications of the smart nanotechnology: smart clothing, sensors, medical devices, aerospace materials also. These are the examples: shape memory alloys, self-cleaning glass, smart bandages, piezoelectric materials, thermochromic materials. Now we can see space technologies. It is also one of the emerging technologies of physics. Space technology is the technology used for space exploration, satellites, and spacecraft systems. Physics principles used in this space technology is rocket propulsion, gravitation, orbital motion, and electromagnetic communication. So these are the some applications we are going to discuss here. So by using this space technology, This space technology can be applied in the communication, weather forecasting, GPS navigation, space research, and remote sensing also. What are the advantages of space technology? If space technology is provided, global communication is running, disaster monitoring can be done, scientific discoveries also done. What are the examples for that? Satellites, space rockets, space stations, GPS systems, space telescopes also. And next, medical sciences, physics in medical sciences. Medical physics is the applications of physics principles in medicine for diagnosis and treatment. Medical physics improves healthcare through imaging and radiation technologies. So whenever you go to hospital, they definitely do some tests. So in the tests there may be the following applications of the medical physics: X-rays, MRI scans, ultrasound, radiation therapy, etc. Importance: to do accurate diagnosis, to do early diagnosis detection, and for the cancer treatments also. Examples: MRI machines are made by emerging technologies of physics only. CT scanning, X-ray imaging, PET scan, radiation therapy equipments also one of the applied physics technology. Next one, biophysics. Biophysics is a branch of science that applies physics principles to biological systems. It studies living organisms using mechanics, thermodynamics, electricity, and magnetism. What are the applications? DNA structure analysis can be done by using biophysics, brain signal studies, and muscle movement analysis can be done by biophysics. What are the importance of this biophysics? Understanding life process, medical advancements, drug development also. So these are the following examples: ECG machines, EEG machine, DNA imaging, artificial organs, protein structure analysis. Next topic, photonics. Okay, photonics is the science and technology of generating, controlling, and detecting light. Photonics uses properties of light for communication and modern devices. What are the applications of photonics? Fiber optic communication, laser technology, medical instruments, optical sensors are the applications of photonics. And advantages are fast communication, high data transfer, low energy loss, optical fiber cables, laser devices, barcode scanners, optical sensors, and LED lights also. This is about emerging technologies of physics.